Okay, guys, we're going to go through PLC timer functions. If y'all have questions, please stop me. We are going to look at retentive and non-retentive timers. We're going to look at the off delay function and the on delay function. We're going to look at but not really use the move function. I'm going to show you kind of how it works. If you want to learn how to use the move function, PLC 2 is where you learn that type of stuff. So in PLC 2, he teaches you how to move and how to make subroutines and how to do the math to compare things and stuff like that. So that is actually in part 2, but we just get into it a little bit so you can see how a timer or counter can be advanced and work better than just the little basic that we're going to do with it. We are going to look at connecting timers together, interlocking them, and cascading them. Okay, so there are 3 types of timers. Okay, these are just in general, there are 3 types of timers: mechanical, digital, and PLC. Okay, so a mechanical timer would be like a clock, an analog clock. You can't see the edge of my screen over here, but there's actually a wall clock like you would see on the clock. It has a hand that moves. That's a mechanical timer. If you have a clock on the wall that's digital, or if your alarm clock is digital or your watch is digital, that obviously would be a digital timer, right? Anybody in here take business classes, typing classes? Nobody took typing? Okay, well in typing classes, they time a lot of stuff. They have timers, and you either have the mechanical one that has the arm that goes around, or you have the one that's got you punch in how long you want it to last and hit a button and it beeps, beep, beep, beep when it's through. That's digital timer. PLC timers are a little bit different. They are internal to the PLC. They will have addresses that are T addresses, but it's very similar to the B's that we've been using. Okay, y'all know what I'm talking about, the binary. These are internal to the PLC. I do not go buy a timer. The PLC has all the timers we're going to need. Okay. So we have 2 functions of the timer. We have on delay and off delay. That means on delay is I'm going to set the timer, and you start something once the time is over. So I might be trying to warm up oil for a motor or something like that. So I have a timer that counts off a certain length of time from the time it turns on the heater to warm up the oil before I will allow my motor to turn on. So that's an on delay timer. The motor won't come on until the timer has had enough time to warm the oil. Y'all okay with that? Yes, no? Okay. Off delay is I am doing something, or the motor's doing something, and I only want it to run for a certain amount of time and then turn off. So this is an off delay. It might be the motor comes on automatically, and every 2 hours I want it to shut down so that we go over there and grease it or whatever, or clean the wood. If it's a lathe or like a CNC mill, we might want it to shut off every so often so we can get the shavings out of the compartment, because we know if it gets too far, it'll mess the machine up. So we want to get those shavings out. So I might have it shut off, turn on the light, so that I know that it's time to go clean out the shavings and go back. Off delay basically turns something off after a certain amount of time. On delay turns it on after a certain amount of time. Okay? I mean, it tells you in its name what it does. These are some timer symbols. Right now, don't worry about those. Okay? The timer symbols, you would use these more in motor controls because you're actually using mechanical timers. In PLCs, what do we have? We have internal ones, but when you put your PLC program up on the screen, what's your choices? For inputs, what's your choices? Open or close. We get contacts. All we get is open or closed. And it's no difference on the timer. You're just going to use the open and closed. You're just going to address them as a timer. Just like you would address a contact as the red light or the motor or whatever. Y'all with me? Okay. This is the way an on delay would work though. So I'm going to close that switch, and when I do, this timer will start counting for 5 seconds. Well, let me say this. Before I do anything, the motor is off and the green light's on. Do y'all see why? Okay. So when I close that switch, it does not automatically close what's open and open what's closed. It leaves it alone. After the 5 seconds, 1, 2, 3, 4, 5, after that time, this will close, this will open. So the motor turns on, the green light turns off. Okay, so this is an on delay timer. This is an off delay. The green light's off, the motor's on. I close the switch. I'm going to assume, since I didn't write anything up here, we'll just go back and make it 5 seconds. I think in the book it says 6, doesn't it? Well, I'm going to make it 5 just because. So, the green light's off, the motor's on. I close switch 2. When I close switch 2, 1, 2, 3, 4, 5 seconds later, this guy will close, this guy will open. So it turns the green light on, turns the motor off. Everybody okay? Once that switch is opened, it should reset everything back and start over. Alright. 8.2 and 8.3, the two diagrams we just looked at, are single input timers. They have one input that turns the timer on and starts the timing at the same time. So it's not like I have to give it power and then turn it on. You understand? It can all be done at one time. There are some that are called double input timers. And double input timers have one input for enable, which puts power to it, and then one for run the function. Okay? So a double input timer looks something like this. Okay? You should have that on 8.4, I believe. we can show it as a coil format or a block. I really prefer the block, but you can see it easier on the coil format. So right now, this IN1 is just an input. Okay, that's just input 1. So what happens is I close this switch, or it'd have to be a switch. So I close this switch. Well, when I do, it tells this timer or this control relay to turn on. So now, oh, I'm sorry, it can't. I have to actually turn the enable on before this will work. Okay? Because I got to get it out of reset mode. So these two control relays are the same control relay. So you got a choice. It's kind of like your latch and unlatch. This is a pull that's similar to your latch and unlatch. So you either have it in run mode or reset mode. So I have to enable it and get it out of this, and then I can run it. Are y'all okay? The off delay, notice that the off delay uses normally closed switches. Let's look at the coil format. They both go into this timer. So this would be the timer right here. And we're going to talk about what goes in that timer, but for now, let's just say that that's the timer. That timer is set for 15 seconds. So it needs both inputs. It's an AND. Alright, since we just came out of that, it's an AND. It can't work with one of the inputs. It has to have both. So I have to enable it, then I have to run it. Everybody okay? Over here, it's already on. What I'm doing is trying to get it to turn off. So I would enable it by turning this guy off, and then I would make it run by turning this guy off. Because this is an off delay timer. Everybody okay? Not to be confused with a countdown timer. I mean, yeah. Never mind. Okay? Okay. We have several registers inside this box. We'll go back just for a second. Oops. I thought I was going back for a second. Inside this box, we have different registers. Okay? We have the preset. The preset will hold the preset number. How many clicks I'm going to have. We have the accumulator register, which tells me how much time I have counted off. So let's say that I've got a 15-second timer and I've made it to 10 seconds and I want to know how far I've made it. Well, I would look in the accumulator register to know I only have 5 seconds more before it does whatever. And in seconds, that's not such a big deal. You could sit there and wait for that light to turn on. But what if this is a 1 hour timer? So you might need to go check and see how far along you are. Y'all understand? Okay. Alright. And then you have the status flag, which tells you the condition of the timer. So, am I timing? Have I finished timing? Am I enabled? That kind of stuff. Okay? So it just tells you the status of the timer itself. Alright. The SLC 500 series, which is the PLC we've been using, has a maximum of 256 timers. They are addressed. Please remember this. T40 to T4 255. They use 16-bit registers. And the smallest increment that you can time is 0.01 seconds. So if you wanted a timer to wait 0.01 seconds, you could do that. Now that's, to me, is sort of ridiculous. But if you wanted a timer that would time 1 hour, 5 minutes, and 12 1/100ths of a second, it'll do that. I don't know of anything that critical, but you could find it. So they have it set to 0.01. So that would be like if you had a digital watch, instead of it counting off seconds, it would count off hundredths of seconds. So you'd have the hours, the minutes, the seconds, the tenths of seconds, and then the hundredths of seconds. You good? All right. We kind of talked about this. The status flags include enable, which is EN. You will have TT, which is timer timing, which that flag is active, or let's just call it active, is active as long as the timer is actually timing. So if I've set that timer that we were looking at a while ago for 15 seconds, only 15 seconds is it in TT mode. Okay. So before I enable it, the TT is not working, and after it's done, the TT is not working. Everybody okay? So if I wanted to turn on the light to see that the timer was in timing mode, I could do that. I'd use the TT flag. So what would happen is, when the TT flag was not enabled, when the timer's not enabled and ready to go, that won't work. Once it's done, it won't work. And I know I'm repeating, but you got to know that. Everybody okay? The done is active when the timer has completed its cycle. So if it's 15 seconds, when it's completed its 15 seconds, a done flag comes on, and you can use inputs called done. So you might have T4:0/DN, and that would tell me that the timer is finished. So if I need to reset it or do whatever, the example we had earlier about the motor that shuts off every 2 hours or whatever, I might want a red light to come on whenever it's done, so that I can, it's kind of like a red flag out here saying, hey, 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 it's time to come clean this machine. And I would use the done flag. That way, as soon as the technician got through, reset the timer, the machine starts working, and this light goes off. So I'm not thinking I need to still go over there and clean that machine. Because as long as it's timing, it's not done. Y'all understand that? Alright, so on delay, we energize when the timer is done. On off delay, we de-energize when the timer's done. We have two kinds of timers. They are non-retentive and retentive. Okay. Retentive means you retain information, or you you retain the information. So what I'm telling you today, if you retain this, you are retentive. I'm not going to make you a timer, and it's only for a certain amount of time when we're talking about a timer. And then non-retentive means that the timer loses its information. So it does not retain it. So if I have a timer that is non-retentive and I interrupt the cycle, let's say I've got a 30 minute on delay timer, and I've got it set, it's non-retentive, and I've got it set for 30 minutes to heat up the oil for 30 minutes before I crank a motor. Okay, let's say it's the dead of winter and we're in Alaska. Just trying to make something really cold. So it needs 30 minutes to heat up this oil before I want to turn on this motor. Otherwise, I might have a block of ice trying to go through there. Okay? It's sitting out here. Will I do something and interrupt the timer and remove the enable? Well, when I turn that timer back on, it doesn't matter that it went to 29 minutes before I interrupted it. Guess what happens? It starts completely over with 0, and I got another 30 minutes. Y'all okay? Understand that. A retentive timer holds the accumulator value when it's de-energized. So I could flip that switch and de-energize it, and if it's at 29 minutes, it's going to start back at 29 minutes. Now, the example I gave you, I probably would never use a retentive timer, because if I stopped it today at 15 minutes, if I come back and restart that thing tomorrow, my oil would only heat for 15 minutes, and I'd still be trying to put a block of ice through there. So you got to think about which timer you need to use. If something tells you that a process is halted, what does halt mean? It's kind of like pause. It doesn't really mean stop. Stop is more like
I mean, it's like stop for the moment.
for the moment. Yeah, there you go. It is stop for the moment, but it probably wants you to start back where you are. If you think about marching, military marching, when you're told to halt, you're not allowed to turn around and go back. It's not a retreat. It's a stop where you are, start back where you are. One of your labs say halt. Read them carefully. Okay? All right. So this would be a timer, easy timer ladder logic. Okay? If I throw switch 1, this is a single input. So when I throw switch 1, it enables that timer. It also starts it timing. Okay? If you notice, this is, can y'all see that? I probably need to, I was going to try to pull out this box, but I don't seem to be able to pull it out. So, but this box, if you notice, it has what kind of timer you're using, whether it's on delay or off delay. Can you see the top? If not, look on 8, 9, I believe. It's in your book. All right, so this is an on delay timer. The address of the timer has to go in there. So where it says timer, that's the address. Everybody with me? Okay. The time base is how accurate do I want to get. The time base is the actual increments of seconds. The preset is how many seconds or how many of those increments am I going to time through. So if I'm using 0.01 seconds, which is what this one uses. Does yours in the book use the same ones? Okay, good. So if I'm using 0.01 seconds, what's your preset? 700. So if I take 700 times 0.01, I come out with 7 seconds. Y'all see how I did that? Alright. So this timer, while it says 700 in the preset, it's going to run through that really quick because those are in hundredths of seconds. So if it has 700 hundredths, then you come out with 7 seconds. So this is actually going to count off 7 seconds. I mean, it's going to count 100 between each second, but it's going to count off 7 seconds. And you can time it by your watch if y'all don't believe me. But it really does. I've checked it myself because I didn't either. So what will happen in 7 seconds? 1, 2, 3, 4, 5, 6, 7. This done flagger, or this done coil right here, will energize. And if you notice, done here will close. And this guy, because it's no longer timing, will open back up. Alright, so let's go back through this again. I close the switch, which turns the timer on. The enable up here will energize at that point. The TT, the timer timing, closes because my timer is going through the cycle, right? In 7 seconds, this TT will only be on for 7 seconds. Once that 7 seconds is over, the done bit closes, the green light comes on, the red light goes off, and the done coil is on. Everybody okay? Be a lot easier to understand and see when you're doing one. Okay, so this is 2 timers together. So, it's just 2 timers in the same circuit. They are not working simultaneously. Okay, so I throw switch 1. Okay, first of all, let's look at this circuit before we do anything. Nothing's working, right? Y'all with me? Alright, if I throw switch 1, what happens? Yeah, I'm gonna close switch 1. Turn switch 1 on. Which timer's gonna start? Alright, T40, right? Alright, so T40 starts working. How many seconds is T40? 10 seconds. Alright. During that 10 seconds, what happens? TT, which is connected to what? TT will be on. It'll close the TT switch. What happens? What is light 1? Is it not in your book as red? Okay. Alright, so light 1 comes on. I called it red, but light 1 comes on. That's fine. Alright, after the 10 seconds, then what happens? Alright, light 1 goes off. That's right, TT opens back up, then what happens? Don't have to. I'm not ready for switch 2 yet. The green light comes on because notice that's T40 done. See DN? So the done comes on. Alright, so now I open switch 1 back up. What happens? Do what? The done is going to open again, which does what? Turns the light off. That's what I'm looking for. So it turns the green light off. You're right, it does reset it. Alright, so now what happens when I close switch 2? The timer starts, and you are absolutely correct. 15 seconds. And what happens? Red light comes on for how long? 15 seconds. After the 15 seconds, what happens? You got it. Red goes off, green comes on. Everybody okay? This is figure 712. It is a retentive timer. Looks a lot like the circuit that we had before in its function. It's still, the first timer is 10 seconds, right? Second timer is 15. We're activating each one with a switch. All I've done is I have motors that come on when it's done and lights that come on before it is, right? Alright, so let's step through this one. I throw switch 1, what happens? T40 is going to activate, which does what? Turns on what? Green light. Okay, I get 5 seconds in and I open switch 1. What happens? Does everybody see that? Because this is a retentive timer, everything stops, but it stays where it is. It just stops. So I open that switch, and it's already at 5 seconds. Well, it's still timing. It's just not clicking off time. But it's still in the timing process. Do y'all understand that? So because of that, the green light stays on. Alright, so I close it and let it finish its 10 seconds. When it finishes 10 seconds, what happens? Green light goes off, motor 1 starts. Everybody see that? Now on the other one, all I had to do was open the switch and everything started over. If I open switch 1, motor 1 is still going to be running and green light's still going to be off. I have to go down to the red PB, red push button down there on line 6, I would assume. Is that the same line for you? And reset it. I actually have to send a pulse to the reset coil. Very similar to the latch and the unlatch. If you don't unlatch it, what happens? It stays latched, right? If you've already latched it, it's going to stay that way till you unlatch it. Well, this is very similar to that in that once you've started that timer, it stays that way until you reset it. Alright, same thing with 2. I throw switch 2. I count off 15 seconds. Or actually, while I'm counting off 15 seconds, the white light is on, right? Nothing else, just the white light. If I halt it somewhere in the middle, everything just stops where it is, and restarts as soon as I close the switch again. Now back to my scenario in Alaska, I could reset it. But I'd have to remember to reset it before I started the warmer back up. Okay. Alright, so when I close this one, TT activates, which turns on the white light. In 15 seconds after this, the white light goes off, motor 2 comes on, and in order to start the process over, I have to reset. The main issue that I see when you use a retentive timer is people forgetting to put the reset in. Then you get it activated, and there's not a thing in the world you can do to start it over until you reset it. So you have to come back out and put this line in there to reset the timer. Everybody okay? All the T4 zeros link to that timer T4 0. All the T4 ones link back to T4 1. Everybody okay? Alright. So now we're looking at another one. Oh, this is the same thing. Same one we looked at before. I don't know how I ended up back there. Alright, so what are the 3 things that when you pull a timer out onto the screen, what are the 3 things that you're going to have to remember to put in your timer? The address of the timer. T4 01 through T4 255. I had to think for a second. It's 256. I just got to remember the 0 counts. Alright, we got to have a time base, which means what? The increments of time. So how small of a time do I want? 0.01, 0.1. Guys, if you're not good at math, okay, make it easy on yourself. If it says 3 seconds, make it a 1 up there and a 3 in preset. That's 3 times 1 second. Okay? Or just remember, every time you move that decimal over, you got to move the other one. So if I want 3 seconds, I'm going to have 30 at 0.1 or 300 at 0.01. Y'all with me? Okay. So make sure that you get your increments right, because if you call me over there and it says 10 seconds, I'm going to be watching my watch. I'm looking for 10 seconds. Now, if it's, 9.5 seconds, am I going to worry about it? Not really. But if I look down, it's supposed to be 10 seconds, and you got 0.01 and 950 down there, what am I going to do? It's only 9.5 seconds, but you've set it that way. So I'm not even going to look at the circuit. I'm going to walk off. And you're going to have to figure out why. I'm not going to tell you. Okay? All right. So pay attention. And then the last thing we have to put in there is the preset, which is what we multiply the time base times. So questions on timers. What? That was just timers, not counters. I thought I had. Oh, well, I opened counters. I guess I closed it. When you get into, if you look at the PowerPoints on Blackboard, the counters have a lot of slides. Okay, it has 56 slides. But there are probably 20 slides that are identical. wonderful. Okay, let's go through counter functions. Counters and timers are similar, okay? A lot of what we learned in timers just a few minutes ago is the same in counters, okay? Chapter 9 is counters. We do have different functions. In the timer, we have on delay and off delay. In a counter, we either have count up or count down. We always have to reset a counter. We can connect different counters together to come up with a process or a use for them. And we can actually combine timers and counters both together. You will do that more so in PLC2 also. There is a lab in here, but that we used to do, but it's a little more complicated and we don't have as much time as we used to have. So now we stop at true timers and true counters. So we don't try to combine the two. If you get through with all your other labs and you want to play around with that, I have no problems with that. But if you take PLC2 next semester, you will do that in his class. Alright, so we have PLC counters and they are used to count parts. That's what we're doing with them. We are counting something. So let's say I have a counter at UPS. Okay? UPS has a counter that counts every box that comes in the warehouse. They have a counter that counts every box that gets put on a truck to go out of the warehouse. So what do they know? Well, I'll just answer that. So at any given time, they know because they can look at what came in, subtract what came out, so they always know how many boxes should be in that warehouse. Now, if an employee picks one up and walks out with it, they don't have that on they don't have that on the count. But every box that comes in and every box that gets put on that truck, they know. Okay? Do what? Now I know, but I'm just saying, it's not on the counter. It's not activated on the counter, but they know that it's not in the warehouse, and it's not on either one of these counters, so it didn't go out on a truck. So we can prove, that it didn't go out on the truck, so when you took it, that's it, All right. Well, you could hide it pretty well.
You gotta go through which car? You gotta go through, they warned you and everything.
Yeah, that's what I was supposed to say, yeah. Alright, or we can count Pepsi cans. Okay, so every Pepsi can that comes down the line after they filled it gets counted. Or Coke. Once I get 6 of them, if it's going in one of those bands, it gets sent to another machine to have that plastic band put on it. Okay, if it's going into a 12-pack, it's sent over here to a cardboard machine that's going to wrap that cardboard around it. Once I wrap the cardboard around the 12-packs, if 100 of them are in a pallet, then I might have another counter that's counting how many 12-packs I've wrapped and set on this pallet until I get to 100. Everybody okay? So there are uses for counters, but counters count things. Counters do not time. On my test, when I ask you what does a counter do, and you tell me it counts for 10 seconds, it is not right. It does not count for seconds. It counts items. Normally what we do with a counter is we have a sensor of some type. It's usually not a manual count. Okay? So we might have a proximity switch that every time one of those cans go past there, it trips the prox. And it might be an inductive switch so that it feels the metal, or it knows that metal has passed by there. So that if I reach down there and put my hand through there trying to fake it, it don't read it because it knows it needs to be metallic. My hand's not metallic. Now, if I was really trying to fake it, I could take a screwdriver or something metal and go through there, and I could fake it. Okay. It could be a beam. If I'm not so worried about it, it could be a beam where the beam comes out of one side, reflects back, okay, to the receiver, or the receiver's on the other side. Every time that beam gets broken, what happens? It counts, okay? What we are going to do in our lab is you are going to flip a switch one time, that's one count. 2, 3, 4, 5. You with me? So don't come back there and throw the switch and say, it's not counting. No, it's not counting. Okay? Alright. We have, on counters, we have double input and single input, just like we do with timers. We can look at them in the block format or the coil format. They have to be connected to a switch for this to work, or some type. I put in their switch in parentheses, but it could be the sensor that we were talking about. But it has to be some kind of an input that it is going to read every time something happens. Okay. It only changes when you go from open to closed or closed to open, depending on which one you got it set up for. Okay. So if I throw the switch up, it's not going to count it on the way up and on the way down. It's only going to count one way, either up or down.
What do you think about these can be shown in block and coil format?
I think that's the next slide. I don't see it. Okay. Okay, so the block and the coil format are the exact same as they are in the timers, only we changed that to count instead of time. Alright, the double input timer, of course, counter, of course, has 2 inputs. It has one that enables the counter and then another one that will do the pulse. So I might want to enable it before I let the cans go past the sensor, okay? Or I may want to, as soon as let the sensor actually trigger it. So as soon as I turn on that sensor, it enables the counter. Okay, the second input counts up or down. The pulses are edge triggered. So for anybody that's had digital that understands edge triggering, if you don't, I'm going to explain it real easy. Okay. It is only going to work when you are throwing the switch up, or the input is going high, or the input is going low. So if we're talking about that beam, it's either going to count when the beam is cut, so the can hits the thing and blocks the beam, or it's gonna be counted as the beams reconnect on the other side. But it's only going to count one time for one of those. It's not gonna count for both. Everybody okay? Are you okay? Yes, but it's only gonna work either going up or coming down. It's not gonna do both. That's really what I'm trying to get you to see. Alright, the single input has one input, and when the sensor's on, it enables it and it sends a pulse for counting. Okay? Same deal. The Allen Bradley that we're using uses single input. The ones we have. So it enables and triggers at the same time. We have, in the Allen Bradley Slick 500 series, we have 256 counters. They are addressed C50 through C5255. The counters and the timers are limited by the amount of memory that you have in the machine. So while I'm telling you have 256 counters and timers, if you put all of those in one circuit, you will run out of memory. Okay? Now, if you have a PLC that you have set up for this, you probably have bought the memory and put additional memory inside the PLC or ordered it with additional memory. That's correct. You'll address them as C50 or C56 or C525 or whatever, but you could even address it as C5255 if you wanted to, and that could be your first timer. I mean, it's entirely up to you what you address it. If you have a circuit, though, that has a lot of timers and counters in them, I would suggest that you somehow give it a name so that you know that this counter is for, going back to the Pepsi example, this counter is for 6-packs. This counter is for 12-packs. This counter is for pallets. And it does give you a place to put notes in there. Alright, so we have two types of counters. This is really, really hard, guys. They either count up or they count down. How many other ways do you know to count? I've never had any sideways, left or right, or east or west, or north or south. It's always count up or count down. So if I count up, that means that the register increments by 1. That means it goes up by 1. I prefer to just be simple and say it goes up. So it counts up. So if I'm on 1, I throw the switch, it goes to 2. I throw the switch, it goes to 3. Throw the switch, it goes to 4. I don't need to keep doing that, right? I think y'all have all passed first grade. So this is first grade simple. Now, countdown does the same thing, okay? But it does backwards, so it's going down. Actually, no, it starts at 0 and goes to minus. Now, the problem is it counts 0. And actually, I'm gonna have to check that and make sure, but it counts 0, okay? Count down counts 0. So on the count up, you're sitting at 0, your next one is 1, okay? With the count down, it actually counts the 0, so that if I need to count down to 7, I'm gonna put it in as 6 because it counts the 0. So it's 0, 1, 2, 3, 4, 5, 6. Okay. So be careful on the countdowns. If you keep doing it and it won't come on, throw it an extra time and you'll realize, oh crap. And you'll have to go back and change the amount. All right. So, we have 3 registers for the counters. We have the preset register, the accumulator register, and the status bit register. They're basically the same as the timer. The preset holds the value that I've counted to. 1, 2, 3, 4, 5. If I stop right there, and let's say the line breaks down and I got to fix something, okay, well, it can hold that 6 half a day. I mean, it could probably hold it for 3 days while I'm repairing the line. And then when I send the next 6 down there, it knows now I got a 12-pack. Okay, so it will hold it. All right, the accumulator register, oops. Oh, that's what we were talking about. Preset would be 12. Accumulator registers, how many I've already counted. And then the status bit is either TT, I guess that's the next slide. I'm sorry, CU or CD. So we've got count up, count down, CU, CD. Instead of TT, the counter doesn't time, it counts. So it's either counting up or it's counting down. So you got a CU and a CD. Okay. Or the done flag. So the done flag is going to energize when the accumulator matches the preset register. And those two match, then my done activates. Same thing with the timer. Alright, now notice that your negative numbers actually have one more than your positive numbers. So on the registers, I'm not real sure why they decided to put this information in there. You never need it. But I have to tell you. Positive numbers go to 32,767. Don't worry about it for a test because I'm not going to ask you this. Negative numbers go to minus 32,768. Well, the reason the negative numbers go higher is because of the way binary is written. You don't actually have a minus sign to tell you that something is negative. The way you know it's negative is it starts with a 1. So if the number has to start with 0, it can't be as high as a number that starts with 1. Okay? That's just another tidbit of information that you didn't need. Alright. So this would be your block format of a counter. And this is the way that when you put it on your PLC screen, this is the way it's going to look. Okay? It is, you have the type of counter that you have. So if you bring in a CTU, that's a count up. If you bring in a CTD, that's a count down. I don't know why T. I guess count. Alright, So the first thing in this box that you have to put in it is the address. Oh, it's supposed to be a square. Is the address of the counter. Everybody okay? C5 something. Then you're going to put in your preset. How many things do I want to count? Well, on this one, it is a 10. Your accumulator is always going to start at 0, so on a counter, you have two things that you have to put in the block format, the block. Okay? You have the address and the preset. In a timer, how many things do you have to put in the block? 3. You have the address, the preset, and the increments. Okay? So the timer does actually count time. The counter does not. It doesn't have that extra added time in there. Alright, so the countdown, notice that I am setting it to minus 15. So guess how many I'm counting down to? 16, not 15.
So you could add a 1.
Do what?
So you basically on that, you add a 1.
Yes. Cause it's just like on your PLC right now. If you address something as 0, what is the switch? It's a 1, right? So this counts, the countdown counts the 0. Everybody okay? You need me to leave it there a second? Alright. We've talked about this already. The count up function, every time you push the button, it counts 1 time. This is how it works, guys. I'll get this because it's going to take me a little while. This is the 20-something slides or 15 slides or whatever. Alright, see the accumulator register real big over to the side? Alright, if I hit the button, if this is a push button and I push the button down, this one is actually on the down swing. Okay, so the accumulator register bumps up by 1. It would normally show in your screen down here. I just didn't want to have to change that every time. Y'all with me? Alright, so I push the button, the accumulator register goes up by 1. And notice that my CU is yellow. My count went again and now I'm at 2. Remove my finger, put it back, 3, 4, 5, 6, 7, 8, 9, 10. When I hit 10, the done flag activates, so whatever I've told it to do at that point, it will do. Are you with me? I may tell a robot now to come over and pick up this stuff and move it to move it to here. I may tell it to bring over the cardboard wrapper to put the cardboard around it or whatever. Okay. Now what happens when I remove my finger? I'm at 10. So everything stays done. I have to hit this reset in order to start over. So this is kind of like a retentive timer. You can't run it until you can't run it again until you reset it. Now what happens a lot of times is I get called back there. Y'all just tested it, make sure it works, but everything's on when I get back there because nobody reset it. And then you're throwing switches and trying to figure out why it's still on. Okay? Alright, count down, I told you, uses negative numbers. You have to count through 0, and it's going to decrease by 1 every time. So here it is, and I don't think I actually counted the 0, but it would count right here. I'd hit the button, and this would be, it would go, it's on 0. So this would already be my second hit right here. 1, 2, 3, 4, 5. And it has to go past 5 in order for that done to come on. Or it actually has to, because it counts to 0 when it gets to 5. Again, I have to hit the reset to start it over. Everybody okay? We kind of talked about this too. We talked about it kind of in UPS, how many come in, how many go out. But there's an example on 9.7. I don't know that my page is correct. I've got page 164, but I think they added a chapter, so I'm not sure that's the correct page. We're looking for figure 9-7, and it looks like boxes on a conveyor. 213. Well, they added a lot of pages, didn't they? Alright, so page 213. They have 2 sensors on this conveyor, and all they're trying to figure out is how many boxes are on the conveyor at any given time. So they count how many are come on the conveyor, they count how many go out, and they shift or move the numbers so that they know that there are 4 boxes on the conveyor. Now here is the diagram for that. Okay. So what we have is that in-feed sensor clicks a count up timer. So every time I put a box on the conveyor, it counts up. You with me? And we have a move every time it counts up. It moves that over into the countdown counter. You with me? So I'm adding to the accumulator every time. So if I've brought in 20, or let's say 10, I've brought in 10. As I bring them in, it moves over and makes the accumulator on the countdown up 1. The move is actually taking the information from the count up timer and moving it to the countdown the countdown accumulator. So, now you're not going to be tested on this either. I just want to show you more complex circuit. So what happens is I count this thing up, my accumulator goes to 1, right? Okay. Well, when my accumulator goes to 1, this move action will move it down here. So this guy goes to 1. Then I do it again. I get another box on the conveyor. This goes to 2. So the move moves it over. This goes to 2. Now, have I taken anything off the conveyor yet? No, because I got plenty of room, right? So I put another one on the conveyor. Now I've got this guy up to 3. So now it moves another one over here. And actually it's moving it, so I really never get it up to 3 when it gets to 1. Now if I do them real fast, it might get, let's say, a 5 up here. Then it would pull that 5 down here. But because it's a move, it drops this back to 0 every time it moves it. It's not copying it, it's moving it. Okay, so it moves this 5 down here. Well, now the outfeed, because that conveyor really will only hold, let's say I'm looking at that 4 that is on there. The outfeed kicked 1 off when it got to that point, right? So that actually came in because it's a countdown. It decrements this number by 1. So it takes the 5 and drops it back to 4. So it's just saying, okay, I'm gonna take these that come on here, move them over here. And then every time somebody breaks that beam and takes one off on this conveyor, it's gonna drop it down one. So if I look at this accumulator register, I can always know how many is on that conveyor. If I get smaller boxes, I might have more boxes on the conveyor. If they're larger, I may only have 2 on the conveyor. So this would be a move function. So I would move everything from my C50, which it shows as a source, and move it down into C51. Everybody okay? I know, a little more complicated. Alright, if I'm going to connect 2 counters together, it's kind of like what we were talking about earlier about counting the 12 packs and then counting the number of 12 packs for a pallet. Okay, I put this in here actually so we could do that, but I'm going to skip over it for now and go to this one. So this guy would be cascaded. It's a little easier for you to see probably. So I'm going to hit that push button one time. What happens? C50 activates and does what? Counts 1. So the accumulator goes up to 1. Alright, I'm going to hit it 8 more times. Now my accumulator is up to 9. What happens when I hit it that 10th time? DN will activate, that is correct, which does what? You are right. It activates the next timer, which is C50. Y'all see that in your book? So it's C50 done. So once it's done, it activates that next counter. What else does it do? Look at line 3. It resets itself. If you're looking at mine, some of the addressing didn't come through, but it resets itself. That's supposed to be C50 right there. So it resets itself. So that means that I can count to 10 again, and then what happens? It counts, it hits a 1 on the other one. We've gone from 1 to 2 now, right? It resets itself and we click off 10 more. So what is the maximum count that this circuit is trying to get to? 50. Does everybody see why? And the preset is not 50. The preset is 10 and the preset is 5. That's correct. It is multiplied, and you're right, it's doing both of them. What you got to think about is each 10 count of the first one activates 1 on the second one. So you're right, you have to multiply them together. Make 50. I'm going to tell you now, there's one like that on the test. It don't say 50. I mean, the answer's not 50, but you better figure out how to do it. We good? Okay, I'm going back to these 12-pack Pepsis. All right, we got 2 or we have a counter that needs to count off the 12-pack. And then we have 2 12-packs.
Are you just saying one girl counts, don't count 12, make a 12 pack,
That's correct.
the other count pack, and
That's correct. So, while we're here, this is a good time to do this. Landon, you take 2. I kind of like this example because it was a little more practical than. Alright, so this is your next lab. For those of you, I think I may have, did y'all turn in your,
still working on that.
alright, so this is the last handout lab, and it is very similar to this example that I have right here. It is going to be cascading counters. When you get to this point in your lab, it's actually the second counter. So I think in your lab book that I have you do the counter lab, which is, I want to say it's 10, but I'm not positive, 10 something. I think you're only going to do part A and then this. Okay. Part B starts putting timers and counters together, and I'm not, that's really needs to be reserved for part 2. Alright. So this lab is very much like this example right here. So the lab says that we are going to automate filling a packet. So a pallet. I do not want hands touching any of these. Okay? So they're going to fill them up. It's going to count the number of cans until I fill a 12-pack. Then I'm going to activate the cardboard wrapping process, and it will wrap them. Then notice that it will wrap every 2-pack for a 24. So it's going to wrap each one of those. So that's the second counter, right? So it has a banding process that it comes over. Then each pallet will contain 25 cases. So the 2 12-packs is a case. 25 cases. So guess how many clicks of the switch you're going to have before you actually have this buzzer come on. Any guesses?
Okay. Okay.
600 times you're going to throw that switch. Now, I'm going to cut it down because I didn't realize that when I was actually building this. The first time we did it last semester, we were sitting there trying to throw the switch and get it to go. Okay? 600 times is a long time. So let's go ahead and change, instead of 25 cases, let's make it 10. 240 is still long, but 240 is a whole lot better than 600. Okay?
When we do this, you want us to do a lap for every little process?
Yes, I do. You will have a light that tells you each one of these is complete. I would suggest, though, you remember to reset it, because What you're doing is you're calling a process. So you're telling the cans to come down, and then that light's just gonna simulate that it's gone over and told the cardboard wrapper to wrap these cans. Or the bander the metal band to come around and wrap 2 of the 12 packs together. And this is not exactly accurate according to what Coke and Pepsi do, but I wanted 3 processes, not 2. Alright, so you should be able to do this. It's fairly simple. Page 2, notice y'all seen this 1,000 times, right? So all you do with it is wire your inputs and outputs, and I went ahead and just did a thing at the bottom. I didn't separate inputs from outputs. Y'all do it. Put inputs on top, outputs on the bottom. But I didn't separate them because I couldn't remember. Everybody's not going to use the same number on each one, and I didn't want to run out of lines. Then you're going to draw your PLC program. I don't have anywhere on here where you have to draw the relay logic, only the PLC logic. This is your grading chart that I do. And I'm so sorry about this last page. Use it for scrap if you need to. But it's actually just giving you the total of your grade. For some reason, the 15 went on another page. But this chart is 15 points. Alright, so questions? Here are your terms you need to know, but they're in the back of the book. You can go back and look at it on this PowerPoint too.